Thank you all. Good to see you. Like they just said, my name is Javier, or Javi, and I work at Twitch in San Francisco. I'm an iOS engineer. I'm originally from Spain, and this is some of the places that I worked at before. You can find me on Twitter at Javi, where I tweet about iOS, but also about other random things like space and chess and airplanes. At Twitch, I work with a fairly big iOS team of about 10 engineers. I would say that one of my main responsibilities is code reviewing. I love code reviewing because it's a great way to learn from one another. I review code, a lot of code, because I like to keep a high quality in our code base. But at the same time, I also learn a lot from by reading my coworkers' code. These are some of the principles that I abide by and try to optimize for when I provide code review feedback. They also happen to be core principles of Swift, which is great. And in today's short talk, I wanted to show some examples of different tips and tricks that I have found to really help when optimizing for simplicity in the code that we write. You may already know some of them, but I hope that you can still take some ideas away from this talk. We often talk about the high-level architecture patterns, but it's more rare that we think about optimizing the way that we write code locally, how to make functions and classes easier to understand and follow. That's what I'd like to focus on today. One of the things that I like to remind myself of when writing code is that we read code many more times than we write it. So taking a bit of extra time to make it simple so that we can make it easier for other people, but also our future selves to understand it. Sometimes we may want to get something done and working quickly, perhaps because we can't wait to get in front of our users. So the question that I like to ask myself when writing code is, will I understand this code and what it was trying to do when I read it again sometime in the future? It's hard to answer that question as you're writing some code because at that time, you probably have a very good understanding of what it does. But learning to critically answer that question and being able to really be honest about it can help develop empathy for other people as well and what they're going to think while reading your code. Separating concerns in code is often seen as a premature optimization when code doesn't have to be reused. But it has huge implications in our ability to comprehend what code does. The way that I think about this is the following. Is the details in this code about how some task is achieved obscuring the details of what is this code trying to do? Let's explore examples of this in Swift and how we can extract the how some code works using tools like extensions and enums so that the core parts of our code can be focused on the what this code does, gaining clarity as a result. Here we have a small example of code duplication. We're counting the length of the strings using utf16.count twice in this method to determine whether the length of the text after netted exceeds some limit. This code is completely fine. When I point it out, most people will probably say it's not worth extracting any code out of this and creating an abstraction. But I would argue that the fact that we're doing utf16.count twice is obscuring the detail that it's actually very important in this context to count the characters in that specific manner. Going back to my earlier point, one way that we can approach this is asking ourselves, when I see this code in 3 months, will I understand and remember why it's using UTF-16 to count characters? So we can very easily create a helper on string that gives a name to our concept. We can call it character count using backend policy. We don't have to even create a different file for this tool. We can put it alongside the code that uses it. But now we can read that code and understand that it's using that specific policy for counting characters that is important for how this is implemented in our backend. Before Swift, we could do this sort of thing in Objective-C by using categories. However, the syntax was a lot more verbose, and you had to worry about things like named collisions with apples methods. But in Swift, this becomes so much easier that I find myself doing this in many more places than I would have considered before. With this code, I can be much more confident that when I read it in 3 months, I will understand why it behaves that way. We've separated the how characters are counted from what are we trying to accomplish. I based this example on some code in our app and simplified it a bit for this example. Now, there isn't anything wrong per se with this code, but let's ask ourselves the same question again and be critical about how easy it is to read this and figure out what it's trying to do. It's not terribly hard, but there is some reading required. The actual code in our app is actually more verbose and has more details than this. It's often that code can be optimized, but we leave it that way because at the beginning, it's not very long. And it's afterwards, as we add more and more features, that now the logic behind the code starts getting more blurry. Here, we're making a network request to get some posts replies, and we're filtering them in line with the rest of the code. What I have done here is 2 things. The first is I've extracted the logic into an extension. This way, the code that uses it contains no details about how the filtering works. It now only points at the fact that it's filtering blocked content. We've greatly increased the signal-to-noise ratio. We've made it a ton more expressive with less code to read. The extension var is also implemented using a functional operator, filter. These are often a great way to abstract away the details of how something is done. They allow us to focus on the task at hand, in this case, filtering a collection. This example is about Autolayout. The Autolayout APIs can be very verbose. This can lead to code with a lot of noise, like this one. Can you tell me at first sight what this code is trying to do? Its goal is actually pretty simple, but it's obscured by the amount of syntactic noise. Apple made this a lot better with the introduction of the layout anchor APIs, but it could still be improved. My coworker Kevin contributed this awesome set of operators to our code base. Now, a lot of us get a little scared with the idea of introducing custom operators and them cluttering our code base. But these have been particularly useful for us, simplifying all the code where we're creating constraints programmatically. The readability of the code that creates constraints without all the syntactic noise of the NSLayout constraint API is just fantastic. So we're using those equals and plus operators to set up our constraints. But we can do even better. Constraining one view to its parent, which is what the initial code was doing, is such a common task that it would be worth having a helper for that. So we can just say, activate the constraints to anchor one view within its super view. This is the before and after. And note that this is not even about the number of lines of code. Even though having less code is definitely not a bad thing, it's about the expressivity of the code. With the new API, the code tells us exactly what its purpose is. We don't have to guess it. This is a very simple one that I picked up recently, and I quite like. I was really struggling keeping track of constraints in views that dynamically updated their layout. And I kept making mistakes when enabling and disabling constraints. So the strategy here is to have an array of the active constraints and make that array be responsible for deactivating the old ones and activating the new ones. So now making changes to our layout is just as simple as setting a new array of constraints. This is a classic one. So many times we have a table view with a known set of rows, and we end up writing code like this that looks at the index paths in several places throughout our class, and it's very fragile and error prone, especially when we want to make changes to this table view. So what we can do here is create a source of truth for the data behind a table view, even if it's a static one like this. Now, if we want to reorder the rows or add a new one, we can do that with our row type, and we don't have to deal with index paths. The goal of this example, is to show the power of simply extracting some code and putting it behind a var property. You may have written code like this, where you're accessing user defaults several times in a lot of places in some file. Instead of this, we can create a variable that's backed by user defaults. Now we can access a value that's really stored in user defaults as if it was a regular variable access. And I think it's quite neat. I decided to include this one because I bet a lot of you have code like this in your app, especially to support iPhone X, iPhone 10. We were doing this all over the place, and we needed to constrain views to the save area layout guide, but that's only available on iOS 11, and we still support iOS 9. So we had to constantly conditionally set up the constraints like this. But then I learned that you can create your own layout guides, and that really changed things. We created our own TW_safe area layout guide. That one will always be available, so we can use it everywhere, regardless of the iOS version. If we're in iOS 11, we can just return the system-provided safe area layout guide. If not, we can create our own layout guide that is simply anchored to the view bounds. The idea here is that whenever possible, we can create a backwards compatible alternative to a new API that, when running on an older OS version, has the legacy behavior. That way, we can write code around our app as if the new API was always available, without having to check everywhere for API availability. How many times have you made a button artificially big so that it could be easier to tap? Apple recommends that touch targets to be at least 44 by 44 points. If we have a button with an icon that's a small image, and we let the button size itself, sometimes it won't be big enough. So we may do something like this, setting its size to 44 by 44. We were doing this in several places in our app, And it meant that these buttons were hard to align visually with one another. Instead of this, we created a reusable UI button subclass called a minimum hit area button. Don't worry if you can't read all the code in this slide. It'll be available on my GitHub, and I'll be tweeting a link later. This class overrides hit test to extend the tappable surface of the button, regardless of the size of its frame. The implementation details don't matter that much. What matters is that now we can use this class instead of making buttons artificially big or hard coding the 44 magic number everywhere. And we'll know that when we have a button and it's of this class, it'll always be easy to tap on. All right, continuing with the UIKit theme, this won't be very new, but we only started adopting this in the Twitch app recently. So whenever you have a dynamic view like this, where depending on the state of the view, we hide or show some views, it becomes complicated to manage the layout. We have to handle different combinations and often manage a complex set of constraints. Instead of that, we can use stack views. Turns out that stack views have this magic behavior where if you set one to its arranged subviews, if you set one of the arranged subviews hidden, it not only disappears, but the stack view will actually remove it from the layout, moving everything around. So managing this state of a view where we want to hide or show subviews like this is as easy as setting the subviews hitting true or false. This might be the most useful thing that I've learned in the past year. All right, to put this last example in context, let me talk about a specific task that I was working on a few weeks ago. The view controller that we use to show a user profile used to be required to be instantiated with a lot of user information. However, in this new scenario, we had to be able to create it with only the user ID. And it would perform a network request to load the rest of the user information. This is what we had before, where we could always instantiate all of the children's subviews right away. But now it needed to work like this, instantiating the view controller with just a user ID, and the rest of user details would come later, and we would instantiate those views later. Again, the code in this slide is simplified from the actual source. In practice, it's very common to have even more views and perhaps even children view controllers. Before, all the properties could be non-optional, but now, because we can't create them during initialization, we need them to be optional. And that means that a lot of functions in this class are suddenly going to have to handle optional views. And that is very error-prone. My theory is that in practice, what's great about optionals is the ability to not use optionals, to make things not optional. And this is another place where enums excel in Swift. I have started including something like this in a lot of view controllers that I work on. Having an explicit state enum, we can use it to associate values only in certain states, so that we can indicate that only when the UI is in those states, those associated views are available. Here we make the network request to load the user details, and this function is responsible for updating the state. Now, every other method in our class can concretely know in what state the UI is in and can pull out the views that are being used without dealing with optionals. And we can handle this state var like this. I'm a big fan of using the did set part of a var to hold some sort of source of truth, to make sure that the state that depends on that value gets updated as a result of that value changing. So in this case, we update which view is visible in our hierarchy, and that var removes the old visible view and adds the new one. Similarly, updating the state value updates which view is visible. so that when we're loading, we show the spinner. When we have loaded, we can display the profile view, etc. To summarize, we spend a lot of time reading code. So focusing on the local patterns that we use to make functions and classes readable and understandable can go a long way in making our overall code base easier to work with. Finding things that keep repeating over and over and extracting them into reusable APIs is useful because in doing so, we can isolate the algorithms and implementation details. So the code that we read most of the time will just focus on what we're trying to do and not so much on the specific details on how it's implemented. And lastly, learn to love enums. They may be the most powerful tool in the whole Swift programming language. Thank you and have a great rest of the conference.